Good morning, everybody. I am Gayatri, Assistant Professor working at Hindustan College of Engineering and Technology. In this PPT, we are going to see about convolution, property of convolution, and discrete convolution. And finally, some examples of discrete linear. The first is convolution. Convolution is a mathematical way of combining two signals to form a third signal. Here, the two signals are convoluted in time domain, which is equivalent to multiplying the sequence in frequency domain. Here, the convolution is represented in linear time invariant system, that is y of t equal to x of t convoluted with h of t. The star symbol which represents the convolution operation. Y of t equal to output of linear time invariant, x of t equal to input of linear time invariant, and h of t is impulse response of linear time invariant. The next topic is about property of convolution. The first property is about commutative property. Here the x of n convoluted with h of n, which is equal to h of n convoluted with x of n. Both are same. The result will be same. The next is associative property. Here x of n convoluted with h of n, the answer again convoluted with h2 of n. It will be same when h1 of n convoluted with h2 of n, and the answer is again convoluted with x of n. Both are same. The next topic is distributive property. Here h1 of n plus x2 of n, the answer again convoluted with x of n. It will be same when x of n convoluted with h1 of n plus x of n convoluted with h2 of n. The next property is a shifting property. Here x of n, the n which represents the sample which is shifted by k times, and h of n, in that the n is shifted by m times. So the resultant will be y of n minus k minus m. Convolution with impulse. Here x of n convoluted with del of n. The result will be x of n. The next is discrete convolution. For a linear time invariant system, if the input sequence x of n and impulse response h of n are given, the output sequence y of n can be formed. This is known as convolution sum, and it is represented as y of n equal to x of n convoluted with h of n, or h of n convoluted with x of n. Both are same. The below diagram which represents the convolution, here the input is x of n and the impulse is h of n. Both are convoluted to get the output y of n. The next topic is about example of discrete linear convolution. Here the method of convolution of two sequences are given. Here x of n equal to a, b, c and h of n equal to e, f, g. These are two sequences. These two sequences are convoluted. The table which represents the convolution of the two sequences, a, b, c which is in a horizontal, e, f, g which is in a vertical. A, B, C are samples of x of n. E, F, G are samples of h of n. Here E and A is multiplied. That is the first sample of x of n, and first sample of h of n is multiplied. This is the first sample of the output. The next step is the next step is here the second sample of x of n and first sample of x of n and second sample of h of n are multiplied. Likewise, you have to multiply the each samples in the x of n and h of n. You will get the output samples. To calculate the number of samples in the output, you have to use the formula m plus n minus 1. The m which represents the number of samples in the x of n and n which represents the number of samples in the h of n. Here 3 samples in x of n and 3 samples in h of n. So substitute in the formula, you will get the number of samples in the output. So 3 plus 3 minus 1 which is equal to 5. So convoluted output will have 5 samples. See the diagram. You will get the 5 samples of the output. This is the way you have to multiply. See the diagram. This is the way you have to multiply the sequence to get the convoluted output. Another one of the example for linear convolution. Here x of n equal to 1, 2, 3 and h of n equal to minus 1, 2, 2. So you can easily find out the number of samples of y of n and you have to use the linear convolution method to find out the y of n. So you have to use the multiplication method to find out the answer. So try to find out the answer for y of n and finally check here to verify the answer. Thank you.